Okay, here we're going to talk about the concept of regeneration when it comes to vapor power cycles. And the idea behind this is to take some hot liquid and use it to kind of preheat the fluid that enters the boiler. Okay? So it has a higher temperature, therefore the boiler does not have to work as hard, with the idea of increasing our efficiency. Okay? There are two types of regenerators that we're going to look at. One is an open feed water heater, where we pull off some fluid from a two-stage turbine. So it goes through part of the turbine, then we pull some percentage off and dump it into a heater where another stream is coming in. Those streams mix and meet at some intermediate temperature that is then put into the boiler. Okay, so then again, it's kind of preheating what goes into the boiler, thus making it have a less input into the heat. So rather than coming in at like state 4 here, like it would without the feed water heater, it actually comes in at state 6, that higher temperature that puts it into the steam generator. Okay, so the one thing we need to figure out is the relationship between these mass flow rates, right? Because some amount of the flow is pulled off, is bled off at state 2 and goes to that feed water heater again to preheat that stream. Okay, so we have this ratio, this percentage of the mass flow at 2 that's pulled away from the total mass flow at 1. Okay, so we have Y, which is basically a percentage. It's a ratio between what's being pulled off versus the total mass flow. So M2 over M1. Okay, now looking at the feed water heater, I've got what comes in at state 2, what comes in at state 5. That's the enthalpy in. Okay, I take them by their specific mass flows. So the first one, again, is that percentage that I'm pulling off. And then 3, 4, 5, the mass flow through those 3 states, is 1 minus that percentage. So if I pull off 20%, then 80% is going through that. And then so at state 5, I got 80% coming in. State 2, I have 20% as an example. And then what the enthalpy out is, again, all of the mass flow at stage 6. So I have, H2 plus H5 minus H6. From that, I can rearrange and actually determine that percentage that's being pulled off from all those enthalpies. So again, with any of these problems, the first thing you do is you go set your states, find those enthalpies. Once I get that, then you can figure out how the mass flows are related using an equation like that. You want to be careful to make sure that the numbers match in. Again, I've got 2 and 5 coming in, 6 going out here. Okay. The other type we have is a closed feeder water heater where the streams do not mix, right? They just interact with each other. Okay, so they can be at different pressures. Okay, because with the open feed water heater, they all have to be the same pressure in order for them to mix properly and go on. So essentially I've got stream 2 to 7 at a different pressure than stream 5 to 6. Okay, they actually mix back here at the condenser. Okay, but the idea is the same, where I'm pulling off some amount at state 2 and using it to kind of preheat what goes into the boiler, making the boiler not have to work as hard. Okay, so once you set your states, again, looking at the feed water heater, basically the heat transfer into stream 5 to 6 equals the heat transfer out of stream 2 to 7. Stream 2 to 7, again, is at that Y percentage, be it 30% or whatever it is. Okay, what's going through 5 and 6 is the total mass flow, right? 5, 6, 1, that's all the same mass flow. 2, 7, 8 has this smaller percentage, and then whatever's left over is at state 3, they mix back in with the condenser. Okay, so you've got these different mass flows of the streams. Basically, Q out of one equals Q in of the other. Solving that for that Y, I can find the percent that's being pulled off. Okay, so as with any problem, first thing you do is you set your states, then you look at the mass flows, and you need to use this to look at the mass flows, and just be aware that the numbers here don't always correspond with the numbers in the problem that you're working on, so just be aware of what's going on with that. But again, the idea here is to preheat that so the boiler does not have to work in hard, thus increasing the efficiency.